enough profits lately.
Well, yeah, I mean, I know. We kind of establish this every other month. Is it worse than it was before?
Yeah, we have so many limitations on how we're making our truffles that profits just don't seem to be increasing.
Okay, calm down. Let me look at this my way. Have some coffee. It's your favorite.
Thanks.
Okay, let's see. I think the best way to look at the situation is to analyze it mathematically, because it's all about the numbers.
Yeah, that's the start. Light bulb! We can use the simplex method and see how our constraints are impacting our way to success.
Yes, I'm telling you, it's the coffee. Go team!
Hi-ho, it's home from work we go.
First, we must identify our constraints to determine how they are affecting profits. Constraints describe the production process, as in how much profit you get for any given amount of input. In our case, we have 3 constraints: forming the batter, freezing, and decorating. Now I'll use red for cookie dough truffles and orange for Oreo truffles. It takes us half an hour to form the batter for cookie dough truffles and half an hour to form the batter for Oreo truffles. It follows as such for freezing and decorating. Since we are open for 12 hours each day, 8 a.m. to 8 p.m., it would take 15 hours per week to form the batter, 30 hours for freezing, and 16 hours for decorating. If we say X is the cookie dough and Y is Oreo, we can form the following linear system of equations using our constraints. It costs us $8.23 to make one batch of cookie dough truffles, each of which we sell for $1, resulting in it costing us 23 cents each. Likewise, it costs us $7.54 to make one batch of Oreo truffles, each of which we sell for $1.50, resulting in it costing us 25 cents each. Therefore, we are making a profit of 77 cents on cookie dough truffles and a $1.25 profit on Oreo truffles. Thus, we can now create our objective function, which is 0.77x plus 1.25y with respect to our truffles. Now, we can really apply the simplex method, which is an algorithm used for maximization. In order to do so, we must add slack variables for each constraint, thus yielding S1, S2, and S3 in the following equations according to our 3 constraints. We have now put these equations into a matrix form, with the objective function being in the last row. According to the simplex method, you take the negative values of these numbers. Now, we must choose a pivot column. This is the column with the smallest number in the last row. In our case, this is column number 2. Now, we also need a pivot row, which we can find by dividing each element in the rightmost column by the corresponding element in the pivot column, which is shown here. You only do this for the first 3 rows of your matrix. Now, we must choose a pivot column. This is the column with the smallest number in the last row. In our case, this is column number 2. Now, we also need a pivot row, which we can find by dividing each element in the rightmost column by the corresponding element in the pivot column, which is shown here. You do not do this step with the last row. We choose the pivot row with the smallest quotient. The intersection of the pivot row and the pivot column is called the pivot element. This should be 1, and since it is, we can now move on to Gaussian elimination. We are doing Gaussian elimination to make all of the elements in the pivot column besides the pivot element 0. In order to do this, we must do the following. We will add negative 0.5 R3 plus R1. We will add negative 1.5 R3 plus R2. And we will add 1.25 R3 plus R4. Thus, by doing these operations, we get the following matrix. Now, we repeat the same method of finding the pivot column and pivot row because our aim is to get rid of the negative numbers in the last row. Our matrix says we must repeat this process. Again, the smallest number in the bottom row indicates the next pivot column. And after dividing each element in the rightmost column by the corresponding element in the pivot column, we once again choose the row with the smallest quotient to be our pivot row. In this case, this ended up being either row 1 or row 2. We considered row 2 to be our pivot row. As we explained earlier, the pivot element, the intersection, in this case is 0.25, but it should be a 1. Thus, we divide the entire row by 0.25 to yield this next row 2. Now, we must perform Gaussian elimination, after which we get our final matrix. According to the simplex method, we can then conclude that x is equal to 30 and y is equal to 24. Therefore, we will be producing 30 batches of cookie dough truffles and 24 batches of Oreo truffles. This will yield us a maximum profit of $53.10 on our truffles per week.
Now what? We're taking control. We get what we want. We do what you don't.
I'ma make it rain. 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 I'ma make it rain.
I'ma make it rain. I'ma make it rain.